Hello friends, welcome back to my YouTube channel. In this lecture, I will discuss two PYQs of GATE Mechanical Engineering which were asked in the year 2006 and 2005. The first question was asked in the year 2006 and it carries 2 marks. And it is based on the concept of energy interaction between the system and surroundings. That is, there are two modes in which energy interaction can take place between system and surroundings, and those are heat and work interaction. So on the basis of that concept, this question is best. Before starting, I must say one thing to all of you: please do subscribe to this channel and of course like it and share it to your friends. So let's get started. You see, there are 5 groups, and under first group there are two terms: heat and work. E is for heat, F for work. These are only the modes of energy interactions possible between any system and surroundings. And under second group is when added to the system. And the third group, whether it is there, which one is exact and which one is inexact, that accordingly will match. And the path function, there are two kinds of functions in thermodynamics. One is point function and path function. Every property is a point function, but only heat transfer and work transfer are path functions in thermodynamics. Of course, another term, that is entropy generation, is also a path function, which you will encounter while studying entropy. And then is transient and boundary phenomena. Those are under group 5. So we have to match. So first we will see, we know that heat when added to a system is positive. You see, suppose this is a system, and this is surrounding, and this is the boundary, and by convention, of course, there is no hard and fast rule. We can change this convention also according to your will. You can change this, but this is the usual convention. When heat is added to the system, it is taken to be positive, and when work is added to the system, it is negative. That means when work is added to the system means work is done on this system, and when work is done by this system, it is positive. So this is the convention. So when heat is added to the system, it has to be positive. So E should be matched with G. And when work is added, here work is added means work is done on the system. We have to supply work from outside. So then work should be negative. So that means E should match with G and F should match with H. ये जो चारों ऑप्शन है यहाँ, ये दोनों में ये नहीं है. ये E G के साथ मैच है, it's okay, but F is not matched with H, so this cannot be the correct option. Then here also you see F is matched with H, it's okay, but E is not matched with G. E should be matched with G. E, G और FH फर्स्ट टू ग्रुप के लिए सही है, फर्स्ट ग्रुप और सेकेंड ग्रुप. So out of these 4 options, only these 2 are the options in which E is matched with G, F is matched with H. So these 2 options, out of these 2 options, one will be the correct. So we will check it. So we will now, the first 2 group is over. Second group, third group. Heat and work are inexact differentials. Why? You see, if we integrate property dV, it will be V2 minus V1. If you integrate dP, it will be P2 minus P1. कैसे होता है? Suppose this is PV diagram, and when a system moves from state 1 to state 2, suppose this is the initial state and this is the final state. This is path A, this is path B. System can travel from state 1 to state 2 through any of the 2 paths. Whatever may be the path followed, whenever system travels from state 1 to state 2, change in volume will remain same. Change in pressure will also remain same, because those things do not depend upon path. They depend only upon the end points, initial and final points, because Whenever the system travels from state 1 to state 2, change in volume will be V2 minus V1. Change in pressure will be P2 minus P1. But what about work? We know that work represents the area under PV diagram. So that's why when system travels from 1 to state 2 under through the path A, what will be the work done? Work done will be the area under PV diagram, this one. And when it travels through path B, the area will be like this. So there will be more work involved when the system travels from state 1 to state 2 through path B. That means work transfer depends upon the path. It does not, it depends upon end states as well as the path. So that's why work transfer is a path function, and similarly also heat transfer is also a path function, and we can't integrate dw like this. And nor can we integrate, and there is a chord sign, is chord sign ये जो है ये differentiate करता है. Only the chord signs are only for heat transfer and work transfer, not for any other thermodynamic any property. It is only designed for the path functions. क्योंकि हम ये नहीं बोल सकते किसी सिस्टम का इस स्टेट में कितना वर्क है, हम ऐसे नहीं बोल सकते. हम बोल नहीं सकते इस सिस्टम का स्टेट 1 पे इतना हीट है, या आई कैन से हीट कंटेंट, बट I can't say the heat of the system at state 1. There is no term like that. You can't define heat of the system at a particular state. You can't define work of this system at a particular state. So that's the difference between the exact differential and inexact differential. So heat and work are inexact differentials. Inexact differentials. And all the thermodynamic properties are exact differentials. When we integrate dV, it becomes V2 minus V1. But when we integrate dW, it cannot be equal to W2 minus W1, because we can't define W2 for a system at state 2. So that's why these are the inexact. Both are inexact. So heat is also inexact and work is inexact. So both will match with J, not any, no one will match with I. Out of these two, heat and work, out of these two, heat and work, out of these two, heat and work, no one is matched with exact differential, because those two are inexact differentials. So that's why both will match with J. So out of these two given options, E is matched with J, F is matched with J. So there is no need to go further. Here both are wrong. E cannot be matched with I, F cannot be matched with I. So this is ruled out. So only option that is left behind is this option D, because both are inexact differential. Heat is inexact differential, work is inexact differential, and both are also path functions. Heat is path function, work is path function. They depend upon the path. So that's why both are also matched with K. So the option D will be the correct option, and we need not go further. So another question that was asked in the year 2005, and it carries 1 mark. The following 4 figures have been drawn to represent a fictitious thermodynamic cycle on the PV and TS planes, pressure volume and temperature entropy planes. So the question was like this. PV and TS plane पे इस तरह डायग्राम था. Figures have been drawn. So according to the first law of thermodynamics, equal areas are enclosed by, options are figures 1 and 2, option B is figures 1 and 3, option C figures 1 and 4, figures 2 and 3. You know, all these are, here suppose this is the PV diagram and this is a clockwise cycle. You know, clockwise cycles are cycles for work producing devices, and anti-clockwise cycles are work work consuming devices like your refrigerator or heat pump. Those are work consuming those devices operate on work consuming cycles. And your heat engines, heat engine is a device which produces work, and its cycle will be in the clockwise direction. So you see, according to first law of thermodynamics, for a closed system undergoing a cyclic process, first law of thermodynamics, for a closed system undergoing a cyclic process, the equation is sigma W cycle is equal to sigma Q cycle. That means net work output, suppose, is equal to net heat input. ये है फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स फॉर a closed system undergoing cycle. It has been established by Joules. You see. So you see this is a clockwise cycle here. And another important concept is area under PV diagram. Area under PV diagram of a closed cycle represents net work output for a clockwise cycle and net work input for a anti-clockwise cycle. So ये देखो एरिया अंडर द पीवी डायग्राम एंड इट इज इन द क्लॉकवाइज डायरेक्शन ऐसे है. So obviously it represents the net work output of a work producing of a cycle on which a work producing device operates. So ये clockwise एरिया जो है रिप्रेजेंट करता है नेट वर्क आउटपुट. एंड सिमिलरली TS डायग्राम पे जो इंक्लूडेड एरिया है, जो एरिया अंडर दिस क्लोज्ड कर्व रिप्रेजेंट्स द नेट हीट इनपुट इफ इट इज इन द क्लॉकवाइज डायरेक्शन, एंड एंटी क्लॉकवाइज होने से डिफरेंट होगा. सो ऑब्वियसली सिंस द सिस्टम कंप्लीट्स ए साइकिल, this area would be equal to this area. So what is the network output? You have to understand that. Suppose a cycle is like this. This is a fictitious figure. This is a fictitious cycle. Suppose the actual cycle is like this. So during these four processes, suppose this is 4, 1 and 2, 3 are constant volume processes. So there would not be any work done. So only work done will be there in the process 1, 2 and 3, 4. So when the system travels from state 1 to state 2 through process 1, 2, work done will be the area under this curve, this line 1, 2, and that area will be this one. This is the total work output, क्योंकि यहाँ work is done by the system. When this system travels from state 1 to state 2, pressure remains constant and volume increases, means this is an expansion process. So work is done by the system. And when the system travels back from state 3 to state 4, work is done on the system, and that area is this one. ये एरिया है. और when the system travels from 1 to 2, net total work done by the system is this one. And when the system travels from 3 to 4, work done on the system is this one. So this is the total amount of work produced when the system travels during the process 1, 2, and this is the work consumed. Work done on the system means work consumed. So this is out of this work, total work produced, this is the work consumed. So what is the net work output? Net work output is this area. So this is our original figure. Original figure was like this. So this area represents the net work output. यहाँ कुछ work produce हो रहा है एंड यहाँ कंज्यूम हो रहा है, जो जितना नेट रह रहा है वो दैट विल बी रिप्रेजेंटेड बाय द इंक्लूडेड एरिया, दिस area of this cyclic diagram. So that's why if it is a clockwise, the network will be positive, and if it is an anti-clockwise cycle, anti-clockwise means work consuming cycles on which the devices like refrigerator and heat pump operate, then there will be network input, वहाँ work consume ज़्यादा होगा, जितना प्रोड्यूस होगा उससे ज़्यादा कंजप्शन होगा वहाँ. So यहाँ in this case you see, and similarly also for TS diagram में जो अगर एक साइकिल होगा, ये अगर this is a Carnot cycle, if it is a rectangle then in a TS diagram this is a Carnot cycle. So obviously included area represents the net, and if it is clockwise cycle, net heat input 1 2 पे heat added हो रहा है and 3 4 पे heat rejected हो रहा है. यहाँ heat added हो रहा है और यहाँ से कुछ rejected हो रहा है. तो suppose this is Q1 and this Q1 heat सिस्टम को ऐड हो रहा है ड्यूरिंग द प्रोसेस 1 2, एंड ड्यूरिंग द प्रोसेस 3 4 उससे Q2 हीट जो है वो रिजेक्शन हो रहा है. मतलब कितना नेट हीट इनपुट आ रहा है सिस्टम को ड्यूरिंग दिस होल साइक्लिक प्रोसेस, Q1 माइनस Q2, एंड दैट विल बी रिप्रेजेंटेड बाय दिस इंक्लूडेड एरिया. सो जैसे पीवी डायग्राम में इंक्लूडेड एरिया रिप्रेजेंट करता है नेटवर्क आउटपुट, इस तरह टीएस डायग्राम पे वो नेटवर्क नेट हीट इनपुट को रिप्रेजेंट करता है क्लॉकवाइज साइकिल में, एंड रिवर्स होता है एक एंटी क्लॉकवाइज साइकिल में. एंटी क्लॉकवाइज साइकिल जो होता है वो पीवी डायग्राम रिप्रेजेंट करता है नेटवर्क इनपुट, एंड टीएस डायग्राम रिप्रेजेंट करता है नेट हीट. वहाँ नेटवर्क इनपुट को रिप्रेजेंट करता है पीवी डायग्राम में एंटी क्लॉकवाइज साइकिल, एंड जो टीएस डायग्राम होता है नेट हीट रिजेक्टेड. अगर हम वर्क देंगे तो हीट रिजेक्शन होगा ना. सो रिवर्स just what happens in clockwise cycle, the very reverse thing will happen in anti clockwise cycle. So यहाँ अगर गिवन ऑप्शंस को हम देखेंगे तो यहाँ ये क्लॉकवाइज साइकिल है, ये भी क्लॉकवाइज है, ये पीवी डायग्राम है, ये टीएस डायग्राम है ऑब्वियसली. सो ये दोनों का एरिया सेम होगा. कभी तो ये क्लॉकवाइज में पीवी है, ये एंटी क्लॉकवाइज में पीवी, ये तो कुछ मीनिंगलेस हो गया. यहाँ कुछ के किसी भी तरह की सेम नहीं हो सकता है. सो 1 and 3 कैनॉट बी द ऑप्शंस, एंड 1 and 4 कैनॉट बी द ऑप्शंस, एंड 2 and 3, ये 2 जो फिगर है ये क्लॉकवाइज साइकिल के लिए है, और 3 जो है एंटी क्लॉकवाइज के लिए है. ये तो कभी इक्वल नहीं होगा. सो अगर ऑप्शन होता 3 and 4, अगर ऑप्शन होता, ये देखिए 3 जो है ये एंटी क्लॉकवाइज के लिए है पीवी डायग्राम में, मतलब ये नेटवर्क इनपुट को रिप्रेजेंट करता है, एंड ये नेट हीट रिजेक्टेड को, ये भी एंटी क्लॉकवाइज. अगर ऑप्शन में फिगर्स 3 and 4 होता, फिगर्स 3 and फिगर 4 वो सही होता, लेकिन वो तो ऑप्शन में नहीं है, क्योंकि ऑप्शन सर फिगर्स 1 and 2, फिगर्स 1 and 3, फिगर्स 1 and 4 एंड फिगर्स 2 and 3. ये तीनों में कुछ भी नहीं होगा, क्योंकि 1 and 3 तो कभी हो नहीं सकता. ये क्लॉकवाइज के लिए है और ये एंटी क्लॉकवाइज के लिए है. ये सेम पीवी डायग्राम, ये क्लॉकवाइज ये एंटी क्लॉकवाइज, कैसे सेम होगा? वो तो सेम नहीं होगा. एंड 1 4 जो है ये क्लॉकवाइज के लिए है और ये एंटी क्लॉकवाइज के लिए है, ये तो नहीं होगा. So out of these given options, only correct option is 1 and 2. 1 and 2. So option A will be the correct answer. अगर ऑप्शन में होता है फिगर्स 3 and 4, वो सही होता है. ये this area is also equal to this area because this represents the network input during the anti-clockwise cycle, or on which the power consuming device operates, and this is the net heat rejected during that same cycle of same anti-clockwise cycle on which a power consuming device operates. So that's why the options 3 and the figure 3 and figure 4 will represent the same area, but that is not given in the options. So that's why the correct option will be figures 1 and 2. So thank you for watching.